On this 2010 to 2015 Honda Civic with the 1.8 gas engine, P16F3 is a starter cut relay 1 control circuit low voltage code. In plain language, the PCM may not be seeing the starter cut relay control circuit behave the way it expects. The car may start normally, may have an intermittent start concern, or may not start at all depending on where the fault is. The possible fault area can include the starter cut relay control wiring, the ignition feed side of the circuit, the starter cut relays, fuse and fuse box connections, connector terminal condition, or the PCM side of the circuit. Before diving in, start with the basic system checks so you are not chasing a simple connection or setup problem. First, try to start the engine. That first result decides which side of the diagnostic path you follow. If the engine starts, go into the code verification step. If it does not start, do not skip ahead and guess at the relay circuit. Move to the starter system data check next. If the engine starts, turn the vehicle OFF, then back on. Clear the code with the HDS, then check pending and confirmed codes with the HDS. If P16F3 comes right back, the fault is duplicated and you can test the circuit directly. If P16F3 does not return, treat it as intermittent for now. Check for poor connections or loose terminals at starter cut relay 1, starter cut relay 2, and the PCM. If captured operating data is available, try to reproduce the concern under those same conditions. With the fault duplicated, turn the vehicle OFF and jump the SCS line with the HDS. Disconnect PCM connector A, the 51-pin connector, and remove starter cut relay 1 from the underhood fuse and relay box. Now measure resistance on the SDCUT-RLYCL line between PCM connector, a terminal No. 51, the pink wire, and body ground. You are looking for 1.0 m-omega or more. If the reading is 1.0 m-omega or more, that wire is considered okay on this short-to-ground check. At that point, update the PCM if it does not have the latest software, or substitute a known good PCM. If P16F3 goes away after the update, the diagnostic is complete. If P16F3 goes away with the known good PCM installed, replace the original PCM. If the resistance is below that threshold, repair the short in the SDCUT-RLYCL wire between PCM terminal A51 and starter cut relay 1. If the engine did not start during the first check, turn the vehicle on, move the shift lever to park or neutral, and look at starter relay control return in the HDS data list. If it shows on, continue with the PCM-side voltage check. If it does not show on, pause this P16F3 path and diagnose the engine will not start symptom first. Next, turn the vehicle OFF, jump the SCS line with the HDS, and disconnect PCM connector A, the 51-pin connector. Then turn the vehicle on and move the shift lever to park or neutral. Measure voltage between PCM connector, a terminal No. 51, the pink SDCUT-RLYCL wire, and body ground. If battery voltage is present, update the PCM if it does not have the latest software, or substitute a known good PCM. If P16F3 goes away after the update, the diagnostic is complete. If it goes away with the known good PCM, replace the original PCM. If battery voltage is not present, continue to the ignition feed side of the circuit. Turn the vehicle OFF and remove starter cut relay 2 from the underhood fuse and relay box. Turn the vehicle on again, with PCM connector still disconnected, and measure voltage on the IG1 ACG circuit between starter cut relay 2 4-pin socket No. 3 and body ground. If battery voltage is present, the IG1 ACG wire is okay, and the open is in the SDCUT-RLYCL wire between PCM terminal A51 and starter cut relay 1. Repair that open. If battery voltage is not present, move on to the fuse check. Turn the vehicle OFF and check fuse No. B2, the 10A fuse in the underdash fuse and relay box. If the fuse is okay, Keep going to the open wire check on the IG1 ACG line. If the fuse is not okay, replace the no. B210 a fuse, and also check that fuse circuit for a short to ground. With the vehicle OFF, disconnect under-dash fuse and relay box connector D, the 32-pin connector. Remove starter cut relay 1 from the underhood fuse and relay box. Install a jumper wire from starter cut relay 1 4-pin socket No. 3 to body ground. Then check continuity between under-dash fuse and relay box connector D terminal No. 10. The yellow wire and body ground. If there is continuity, the IG1 ACG wire is okay, and the under-dash fuse and relay box is the remaining failed area in this path. Replace the under-dash fuse and relay box. If there is no continuity, repair the open in the IG1 ACG wire between starter cut relay 1 and the under-dash fuse and relay box. Keep verification separate from the circuit testing. After the correction for the branch you followed, confirm that P16F3 is no longer indicated. The key on this one is to let the starting result and the HDS data split the path, then prove whether the problem is a short, an open, a fuse feed issue, a fuse box issue, or the PCM side before replacing anything. For more diagnostic training, visit Diagnostics.com.